Okay. All right. So today we're going to do a little bit of just understanding a little bit of how our brain physically, the neurology and the cognition behind the reading brain. So I know that we are not all scientists, and trust me, I am not a scientist for a reason, but I do think having an understanding of what's going on in the brain as somebody is reading can help us to better understand when and how we need to do interventions to support a reader. And even though a lot of this is going to have more immediate application for teachers who are teaching students how to read, I think for those of us, like most of us in this class who are working with older students, it also helps us to understand what might not have occurred before, in the earlier years, so that when we're designing and identifying interventions for our students, we have a better understanding of what might help them. Okay, so first thing I want you to know is, as a system, the idea of language as a written system, that's a relatively, that we're talking about a couple thousand years as opposed to speak, or as long as humans have been on this earth, they've been developing speech. So our brains through evolution have actually developed parts of the brain that are created so that we can understand speech, so that we can create meaning with sounds. Print, on the other hand, because it's only a couple thousand years old, that's a relatively new concept. So our brain hasn't evolved to naturally learn how to read and write. And so that's a system that we need to develop and that's a system that particularly those teachers in the pre-K through third grade realm are really working on, is helping them to move what they know naturally about language through speech, to use that to help them to understand the printed word. So it's a concept of understanding that we actually are, as teachers, we're actually physically changing the brain. And that's true even when we're working with adolescents. We're physically changing the brain, and understanding that is important. So you probably, at this point, if you haven't already, you might want to just download this so that you can throw some notes on here. Not so much that I necessarily want us to memorize it, but because I think processing it in writing will help to get some of these concepts down. But we should understand the brain has different parts to the brain, right? And each of the different parts function in different ways. They have different responsibilities. You probably have heard of the frontal lobe because of our discussion in like adolescent literacy about the development of the prefrontal lobe, how the front part of that lobe is underdeveloped in adolescence. And that's where we identify a lot of issues with judgment and impulse control coming from that prefrontal lobe. So none of these parts of the brain are exclusively dedicated to language or reading, but it is important to know that these parts of the brain have roles to play when we're learning how to move our knowledge of language that we got through speaking into writing, okay? So what role does each part play? Well, the temporal lobe, which is right here, that's responsible for helping us discriminate sounds. That's actually the part that's been developed so that we can understand speech, okay? So phonological awareness is when we go through things like when you were little and you sounded out at, and you came up with the word cat, right? You understood each one of the sounds in that word, right? You probably have memories of your phonics and phonics education to get yourself to there, right? So that's where we store our verbal memory. So this is, so in the prefrontal lobe, or in the temporal lobe. The frontal lobe is where we handle speech production, but it's also where we hold our reading fluency, our understanding of language or grammatical usage, both verbal and written. It's where comprehension, like meaning making, really happens. And it's where we start to really be able to move from simple to complex in our native language. That's in the frontal lobe. The parietal lobe, which is just behind that links, this is a really important part because this is what links the spoken and the written language to memory, so that we can start to store meaning, so that we can start to understand what we read and what we hear. So even though the sound production comes in here, the meaning making has to, so when we hear a word spoken to us, we're breaking it down in this part of but to retrieve its memory, that's in the parietal lobe. And then the acceptable lobe, which is the primary visual cortex. And it's where this becomes really important because language that is written, right, that is something that you need, that's a visual cue. And so that gets involved when we start to talk about reading and writing. So that's the occipital lobe. Okay. So what happens then is proficient readers need to figure out how to move this, the language, how to move and make pathways across different of these various parts of their brain. So how to hear at, start to see CAT, understand what that means, and begin to start to comprehend. And so what happens here is that proficient readers develop a neural pathway from which is this blue part here, right, that helps us to connect what we hear, right, so the green, with the symbols, the pink. And so we have to keep developing these pathways, and it's a very, very, very complex, but also, if we're doing it well, automatic. It's happening very quickly. Okay. So when we're reading something, then we're actually activating whole different, it's like an explosion in the brain, and we're going, and all these different parts of the brain start to get to work so quickly that we're not even recognizing that we're doing it. It happens so quickly. A lot of times before I took some training on the science of reading, I thought, okay, when we read by word. We actually read letter by letter. And that is something that we do so quickly. That's why it feels like we're reading it word by word, right? But so this explosion that happens is really, really, really just so quick, and everything seems to be happening almost nearly at once. Okay. So what we want to think about then is all of us, regardless of whether we're literate or not, we have some of the same mental pathways. So this is what happens in a brain that is in various stages of literacy. Okay. So when the brains of all three of these people, when they hear spoken words, notice that pretty much the same parts of the brain are lit up, right? This is actually coming from imaging, brain imaging. So even somebody who doesn't know how to read, they are using the same parts of the brain. Now, if we give them a written sentence, though, notice that somebody in the illiterate part, this is lit up. Why? Because it's a visual cue. You're showing them something, and so that visual cue is there. But notice that the rest of the brain really is very inactive, or mostly inactive. That's because there's no pathways to help what I see to move into the parts of the brain that I need now to make sense of it. Once we start to move into literate, newly literate, you'll see that the pathways, so you start to see, yes, the visual part is lit up, but so too, this is what we call, this is like the pathway that has to form so that we can move it into the part that helps us to make meaning. So in here, they can make meaning out of spoken word, but here they're starting to be able to make meaning out of the written word. And then we're talking about a fully literate person. You can see that this part stays the same, but where the pathway is strengthened is over here in the meaning making. This is where it is most developed for those students who know how to read. Okay, it's really kind of fascinating to think about that. So this is one of the reasons why we know that we learn to read from speech to print, because we see the processing that's happening. And we see that the processing is there regardless of whether or not we can read or not for the spoken, but that it needs to be developed for the written. Okay, so going back to that, then we're going to think about then, how do we get there? What is involved in being able to create this, what you saw in that image? Okay. So before I begin, I just want to take a second to kind of explain why we are a bit more complicated than some languages, okay? English is a very, what we would call a deep orthography. And what that means, and that's not like a judgment, it's literally just a term that linguists would use. Linguists study two aspects of speech, the spoken, the phonology, and the written, the orthography, right? And so in a very, in a very shallow orthography language, or yeah, in a language with shallow orthography, the way it is written really mirrors what you hear. So all of the symbols directly correspond with a sound. English, because it's come from so many, like there's French influences, there's Greek and Latin influences, there's Spanish influence. There's so many different languages that are kind of synthesized into what we now call modern English, right? English is what we would call a deep orthography. So our system is both sound-based, meaning that sometimes the syllables are represented by the sounds within the word. So the at, that's very, regular, that's right. But we also have what we call morphemes, which are meaningful parts that are not necessarily spelled out as sounds. So you start to think about this, and you can think about the irregularity. So when I write something, when I say something like right, that's pretty fairly follows the phonology. Although I will say we also have more sounds than many languages. So I think there's something like 18 identifiable sounds in some languages. There's 42 to 44, depending on how different linguists in the English language. So that's one thing. We have a lot more sounds that make it up. But then also you think about things like, a word like native. N-A, native, national, nativity, all of those kind of make us think like the N-A in there, it goes across each word, which means that there's something in that word that's about birth, right? Something in that word that's about birth, and we start to understand that. And that's what we call, and when we get into talking about vocabulary instruction, that'll be an important part to consider. All right, so going back then into the brain and how the brain works then. So as I said, proficient readers then are taking these sounds that they have, they're moving them into recognizing the letters that create that sound, but they have a lot more to do than just the letter sound recognition, the sound symbol connection. So we have to really move through these parts of the brain very quickly. So I liked this visual because I really thought that this visual showed you kind of what that explosion might look like, okay? So what happens then, going in here, I look at a word, so it's going to come in here as a visual, right? I'm going to move to my sound symbol connection and what I know about the speech to be able to start to bring meaning to the word, okay? So there's this little place called the letterbox in here, which allows me to sort of start to create sort of a little box of words that I can recognize fairly quickly. Okay. And so this is where we start to see the explosion, and you'll see that we are constantly moving back and forth, and look at how the arrows are back and forth and back and forth. So this is the visual word form area right here, the letterbox that I talked about. So we start to get more and more efficient. This is why I said earlier, you start to think, oh, I actually read word by word. You actually don't. If you ever got to a word that you don't know at all, that you've never seen before, you'll actually recognize that you have to slow it down and you're actually going letter by letter. You're doing that the whole time. It's just that this part has gotten so strong, the connection is so strong on some of them that you are able to just kind of very quickly pull it out. So then what happens is I get a word, right? I look at a word, I move it back here to the visual, and then the visual is just quickly pushing it to all parts. It's pushing it into so that I can access the phonological, right, the pronunciation, and it's pushing it up into the parietal lobes so that I can start to access the meanings, right? And so we can see this start to happen very quickly for our for our reading. And so what happens then is the brain is just exploding and the inputs are being segmented all across the brain. So the brain reads by creating pathways between the parts that process speech and those that process reading. The pathways involve the left hemisphere of the brain, and that includes multiple parts of the brain. And because humans have not been reading and writing orthography as long as we've been speaking, learning to read is not natural and involves making connections between speaking and reading and writing.